Okay. So continuing with the process, yeah, microscopic domain. Okay. Now, when you talk about microscopic domain, micro, what do you understand by the term micro? Micro means very small. Micro means very small. So when we speak about the microscopic domain, what we say, these are the observations or studies that cannot be made through naked eyes, but require optical instruments or optical devices to do so. Optical devices means visionary devices which requires. So any of these observations or studies that require optical instruments for doing and cannot be done by naked eyes are termed or come under microscopic domain. So you use a microscope for this phenomenon. You use a microscope for this phenomenon. For example, study of cells, study of tissues. How do you do? You do using a microscope. You cannot do it with the naked eye. You cannot see a cell. You cannot see a group of cells or tissues with the help of naked eyes. What do? You use a microscope for doing so. So because you use a microscope for doing so, you term these observations or studies under microscopic domain. Okay. Now, as you know, microscopic domain and macroscopic domain, these are the basic observations that you'll be doing. Okay. Now, I'll ask a simple question and then we'll move ahead. What do you think? What do you think will measurement of time come under? What do you think will measurement of time come under? Measurement of time. Measurement of time. Will it come under macroscopic domain or microscopic domain? Yes, Prakhar Bhumia has come up with the magnifying tools. Yes, magnifying tools can be one of them, but or not all magnifying tools. Beta. Suppose it is a magnifying glass. So even from a single magnifying glass, you cannot see cells. Okay, and remember, when you talk about magnifying tools, when you talk about a microscope, what microscope you see in the biology labs, specifically that is what you have seen. They are not simple microscope. They are compound microscopes, which don't have one lens, it has combination of lenses. Okay, magnifying glass has a single lens. So that you will be studying in class 12. However, for your basic knowledge, remember the microscope that you see in biology lab or in different laboratories, they are the compound microscopes. They are not simple microscopes. And when you talk about magnifying glass, it is a simple microscope with a single lens. Okay. Yes, so most of you have come up with macroscopic exactly. So we'll be doing the observation of time into macroscopic domain. So this thing is clear to you. So I move ahead with another part. Now let us come and study some basic or fundamental forces in nature. Some basic or fundamental forces in nature. When we talk about the basic fundamental forces of nature, so which is the first basic force, fundamental force that comes to your mind? Text fast, quick. Which is the first fundamental force that comes to your mind? Quick. Hurry up, hurry up. Think, I want you to reply fast. Quick, please. Gravitational force. To be very precise, it's gravitational force. So gravitational force is the first basic force of nature that we are going to study. Okay. Although you will study a detail on this also, we have a chapter on this in class 11th, that is gravitational. Okay. Earth's gravitational forces, other things you'll be studying in this particular chapter. So, gravitational force. What is gravitational force? When we talk about gravity, one general term what people speak is gravity, Earth. This is the only thing that people speak, or this is the only thing that students generally say. Gravity, Earth. The force exerted by Earth is gravity. The force exerted by Earth is gravity. Let us be more elaborate on that. It's not only the Earth, brother. It's not only the Earth. If there are two bodies which are placed, there is also a force acting between these two bodies. Simple bodies, uncharged bodies. Okay. Still, there is a force acting between any two bodies, and that force acting between two bodies kept at a distance apart is termed as the gravitational force. Point number one. Point number two. When you talk about why it is termed as gravity or why it is termed as gravitational, because the meaning of the term gravity is pull, attract. The meaning of the word gravity is pull, attract. And gravitational force is always and always and always attractive in nature. Gravitational force is always attractive in nature. See, when you talk about magnets, so magnets from class 6 or junior classes, we know like poles repel, unlike poles attract. Okay, like poles repel. North and north is there, it will repel. South and north is there, it will attract. But in case of gravitational force, there is no sort of repulsion. Remember, in case of gravitational force, there is no sort of repulsion. There is only and only and only attraction. So when you talk about gravitational force, we talk about force acting between two bodies, or the attractive force acting between two bodies is termed as gravitational force. Yes, yes, Pratham, you are right. Okay, so gravitational force, the force of attraction acting between two bodies, any two bodies. Okay, when you talk about our solar system, so Earth and other planets are moving around the sun. Force of gravity, gravitational pull of the sun. In case of Earth, you leave an object, it goes down. Why? Gravitational pull of the Earth. So gravitational force is the force acting between two bodies. It is always and always attractive in nature. Thing number one. And thing number last thing that you got to remember is gravitational force is very weak. Gravitational forces are very weak forces of nature. Remember. Okay? Okay. Let us come on to another force. And let us talk about strong nuclear forces. Let us talk about strong nuclear forces. So when you talk about strong, you talk about strong nuclear force. So the term over here you see nuclear. Okay. So we are directly talking about nucleus. We are directly talking about nucleus. When you talk about nucleus, what happens inside a nucleus? Nucleus holds protons and holds neutrons. Many times in chemistry, you might have heard or studied in class 10 that electrons are removed. Okay, electrons are removed from an atom, electrons are taken. So if it is removed, it gets positive charge. If it is taken, it gets a negative charge. So electrons removal you have seen. But have you also seen, that we talk about protons removal? Do we talk about the removal of neutrons? No. Generally what you have studied up till now, you've studied removal of electrons or adding up of electrons. This is what you've seen. So that means nucleus holds this protons and neutrons with a high force, or I can say, or we can say, term it as binding force. Binding. It has binded the neutrons as well as the protons. So nucleus binds. So these forces are very, very, very strong, and we term them as strong nuclear force. So I can term it the force with which a nucleus binds the protons and neutrons. They will be termed as strong nuclear forces. They will be termed as strong nuclear forces. Quite clear? Okay. Now, if this is strong nuclear force, what would be what would be a weak nuclear force? If these are strong nuclear forces, then what would be the weak nuclear forces? I hope many of you would have made a guess. So weak nuclear forces, they are not weak means they are very weak. No. Weak means they are very weak. No. Still they are very much greater as compared to gravitational force. Weak means if the nucleus, the force that which binds, the nucleus binds the protons and neutrons is strong nuclear force. The weak nuclear force is the force with which a nucleus basically binds the electrons. Basically binds the electrons. And in a higher way, you can say alpha decay or beta decay. But as you don't know alpha decay and beta decay, I'm using a simple term right now. That the forces at which a nucleus binds the electrons revolving in the particular orbits. But of course, in chemistry, there is a nucleus and electrons keep revolving around the nucleus. They keep on revolving. That means here there is some force that has binded, that has bounded to move in a solar path. There isn't a rope tied. Don't think the game of rope. So there isn't a rope tied. So they are still electrons are revolving. That means some binding force is there with the nucleus and the electron. But these electrons can be removed by doing some work or by giving some energy. And as they can be easily removed, as they can, depending upon the size of the atom, they can be removed. So these forces are termed as weak nuclear forces. The forces acting between, or the force that binds the electrons revolving around the nucleus to the nucleus. Okay, let us come on to one more basic force of nature, that is electromagnetic forces. Electromagnetic forces. So we have two parts in this: electro and magnetic. Two parts. One is electro and one is magnetic. So as we have two parts, first I am going to tell you about electro. Electro, I elaborated, and this will be electrostatic forces. Electrostatic forces. Now you will see again I have broken this into two parts. I have again broken up into two parts: electro and static. When you speak about the term electro, you speak about the elementary charged particle, that is the electron. It's not only electron, but one of the basic elementary charged particles, that is the electrons. Elementary charged particles are both electrons as well as proton, the most elementary basic part. So when you talk about electron, you talk about charges. When you talk about static, you talk about state of rest. When you talk about static, you talk about state of rest. So our student has answered the force acting with the combination of electricity and magnetism. No, beta. There is a difference. There is a difference. Okay, I'll come on to that. So electrostatic, charges in the state of rest. So the force acting between the charges in the state of rest is termed as electrostatic forces. So the force acting between charges in the state of rest are termed as electrostatic. Remember, electrostatic charges static in the state of rest. So the force acting between charged particles in the state of rest are termed as electrostatic forces. Now what about the second term over here? Magnetic forces. Magnetic forces. The force acting between magnetic particles. The force acting between magnetic particles is termed as magnetic forces. So the thing is, why these two have been combined? Why these two have been combined? They have been combined for a reason. When the charges are in the state of rest, electrostatic forces. When the charges are in the state of motion, they constitute electric current. Perfect. They constitute electric current. And we very well know that a current carrying conductor produces magnetic field. A current carrying conductor produces magnetic field or behaves like a magnet. Behaves like a magnet. So when the charges are in the state of rest, the conductor would behave as a magnet, and if you will bring another magnetic material, so there will be a force acting between them, that will be magnetic. That will not be electrostatic. That will not be electrostatic, that will be magnetic. Got it? So the two parts are electrostatic, the force acting between charges in the state of rest, and magnetic, the force acting between magnetic materials. As well as if the charge is in motion, it will show magnetic properties and would show forces with magnetic particles. And hence they are termed as electromagnetic forces. And electromagnetic forces are also greater than the gravitational force. So the weakest force is the gravitational force. Okay, so these are the basic forces of nature that we studied today. This is the basic of chapter number 1. There are few theoretical aspects that I will be forwarding it to you. You may just read it, and if you have NCERT textbook, you may read those things. These were the major highlights and important points for chapter number 1. Okay, now in the next class we will be studying and going ahead with the important aspects of the second chapter on some mathematical concepts that we are going to do and go ahead with physics in coming time. Okay, so for today it's here only. It's just the basic, just the start and to warm you up. Okay, thank you very much. Have a great day.